You've read the rules, you've created your strategies, you've put in the time, you've done the math. Now it's time to show us what you've got. Welcome to this week's episode of FMA Plus.
Welcome to week 2 of FMA Plus. We're so excited to highlight another 5 team stories this weekend with you guys. Tonight we've got Team 1089 Mercury from Hightstown, New Jersey, Team 2729 Storm Robotics team from Marlton, New Jersey, Team 225, they're from York, Pennsylvania, that's Tech Fire. We've got 7587 Metuchen Momentum from Metuchen, New Jersey, and we've also got Team 747 Flight Crew from Middlesex, New Jersey. Our first team tonight, Team 1089 Mercury. They're from Hightstown, New Jersey. They've already competed this season, so they wanted to tell us a little bit about their journey through the competition season and their robot, knock on wood.
All right, so we're Team Mercury 1089 out of Hightstown, New Jersey. We're a big team made up of around 80 students. We break up into 7 committees, 4 technical committees and 3 non-technical committees. Each committee has their own set of committee chairs as well as mentors. We modularize our tasks to get a lot of work done out of everyone. We like to modularize our tasks, but we also like to do stand-ups and maintain a task board such that we can keep all our mentors and members in the loop of the happenings during build season. What we wanted most out of our students this year was for everyone to get a positive experience out of the build season.
Awesome. So let me ask you, Ethan, you said stand-ups. Are you referring to stand-up comedy, or what do you mean by stand-ups?
So stand-up on our team is kind of after our dinner on long nights. We tend to get all our student leaders from all the committees, as well as our mentors, as well as our advisors, and we like to get together and go through our task board. So we talk to one another about the tasks that need to be completed, tasks that we need help with, tasks that are blocked by another committee, and it's just a good way to make sure that everyone knows what's going on in the team, so there's less confusion during the build season.
Okay. Jack, let me ask you this. When it comes to new students or maybe less experienced students, do you guys do anything in the preseason to prepare them or get them ready for robotics?
Yeah. So from a design perspective, we do a lot of training workshops with like our 3D modeling programs and stuff like that, so that when it comes time for build season, they're more prepared. So this year we actually picked up a new mentor that transitioned us to SolidWorks. We've been using Autodesk Inventor for the past couple of years, but we transitioned to SolidWorks this year. And so he helped us with that after using it for the industry for like 30 years or so. So that was really nice. And we also integrated using GrabCAD this year, which was a big change. And with that, our new mentor helped us create a component library during preseason. So we had kids working on that to help their modeling and, adding in, part IDs and stuff like that into the library. And that made build season really easy because we could just grab all the COTS parts from this 3D component library, and it made modeling a lot faster.
So one of our goals on the Programming Electronics Committee is to keep it sustainable, keep the new members coming in and building up their skill sets. So over the past 3 to 4 years, we've been building upon our code base and optimizing our existing code. That way, all of our code is robust and strong. We have a command-based system. We use WPI library, and it makes it easier for us to break up into project groups and delegate roles to project managers and then have them have their own groups inside of that. The project managers are working with students one-on-one or in small groups to complete tasks and get them to learn more about the task itself, whether it be vision processing, color processing, which we saw more with the control panel this year, motion profiling, autons, and things along those lines. Specifically with electronic skill sets, we teach them how to wire the robot in an organized fashion, how to solder and crimp, and basically all the components, all the physical hardware components that you need on the robot. So all of these processes make it much easier to train new members and get them integrated into our committee and working.
Wow, that's killer. It's one thing to have a strong programming presence and a strong programming team, but you guys actually have designed a process and a system to maintain that level of programming efficiency for years to come. That's super smart and really, really commendable. But Nihar, We've talked about the programming. We've talked about how your team is set up and what you guys do to prepare. But now I want to know what you guys have made. So Nihar, why don't you run us through the robot?
Yeah, absolutely. So this year we named our robot Knock on Wood. We used a West Coast drive, 8 wheels, so 6-inch Colsons all around with a double drop center. We used a WCP single speed gearboxes with 4 Falcon 500s, 2 on each side, which gives us a rough speed around 15 feet per second. For our intake, we had an over the bumper intake with that actuated in and out, and we used a John Deere roller material from the kit of parts. So when prototyping, these rollers proved to be more effective than some compliant wheels and other things we prototype. Then for our hopper, it's sloped towards one side and has a polyurethane belt that pulls the balls into the feeder. Then the feeder, it has 4 compliant wheels, 2 4-inches and 2 2-inches. And these are used to stabilize and center the ball when it brings it up into the shooter. It also has a double-sided timing belt on the opposite side that are used to turn both axles in opposite directions when we only use one motor, and it keeps them synchronized. Then we have a hooded shooter that uses Fairlane wheels. So the shooter runs at different RPMs based on the distance that the limelight gives us. And this gives us around 18 feet of range. So usually where we like to shoot from are in front of trench and initiation line. And using limelight, it makes our shots super accurate because it automatically aligns the base. So although we didn't have a climber for our first event, we put a lot into a little space and we were pretty happy with how we turned out on the field.
At the start of the season, we defined 4 design priorities. The most important was to have a touch and own floor pickup. So as soon as we touch one of the game elements, we wanted to make sure that we would grasp it efficiently and quickly. We knew that Infinite Recharge was going to be a cycle game, so we needed fast, protected cycles through the trench run. And so to do that, we decided to build underneath the control panel. So that would allow us to move more efficiently across the field. We also wanted to climb to get those good points at the end of the match, as well as those ranking points. And although it was less of a priority for us, a control panel mechanism was something that we wanted to build.
Okay. So you guys have these great design priorities, and it seems to be like a vital part of the design process, right? You need to know what you're going to do, what your robot's going to do, and why it's going to do it. So Jack, how did you get from your design priorities to your robot? Like, can you walk us through the decision-making process?
Yeah, absolutely. So once we have like these list of parameters that we have towards building a robot, we start doing some basic research and design work for the actual machine, right? So the first thing obviously is getting at the drivetrain. So we knew that navigating through the trench underneath the control panel quickly and easily was critical to our design. So we like to go for a longer drivetrain over a wide one for that reason. And we also wanted to reduce the turning scrub when aligning to shoot. So an 8-wheel drive was effective on that because you would only actually be on 4 wheels on a double drop center when you're aligning. And that would also make it easier to go through the rendezvous point. So that was definitely an advantage. Another mechanism that we had done a lot of focus on was what we like to call our sexy intake, which is a shout out to my boy Tyler Lucas for basically single-handedly designing. So a lot of credit to him for that. And we call it that because of the lightning bolts that we actually had CNC'd into it, and access to a CNC this year was a brand new thing for us. So it was actually our first fully fabricated subsystem powered by a snowblower motor, which actually had a clutch on it, so that on the field, when we were bringing it on and off the field, we would actually be able to manually raise it and lower it. We didn't even need to iterate the design. So once we put it out and we were able to fabricate it, we didn't actually need to iterate it at all. It kind of just like worked. It's just super robust. It just never failed. And so we're really proud of that. So our shooter, we prototyped a couple different designs, 2 of which being like a dual wheel prototype, like two side by side wheels, the power cell would go in between them, and another wheel that was a single wheel with a hood. And so we elected to go for the single wheel with the hood because we found it to be more accurate in our prototype. And our dual wheel prototype actually became our feeder. We turned it 90 degrees and had the ball go into the dual wheel and shoot the ball up into the hood. And so that actually worked out really well, and it was actually modified to be our final design. And then finally, our electronics board, which we kind of treated, unlike previous years, as its own kind of subsystem this year. In past years, we had kind of just like slapped electronics and wires in at the end, like a lot of teams do, and it doesn't really go that well. So this year, we kind of treated it as its own thing. We designated space really early for camera mounts, wire placement, stuff like that. And that made like competitions a lot easier. Everything was accessible. And yeah, so we were really proud of our design this year. We were proud of the decisions that we made. We had a lot of new students being integrated into the CAD and the decision making. And so although it was kind of slow to compete, part of the reason why we weren't able to have a climber was because of that. Come time for Happero, we were proud of how we were able to say that we owned a lot of the design. It was very student design, so we were proud of that. We were also proud that the process that we used to get there was very structured, and we definitely could see a way to build off of that in the future years.
Yeah, Jack, let me ask you. You said that one thing that you noticed was that while you're super proud of what you produced and how you got there, that you were a little bit slow to reach completion, which obviously impacted your climber execution. Do you have any ideas on how you might improve to maybe avoid that or reduce that impact in the future?
Well, I think a big thing we've always struggled with as a team is communication between other technical committees. And I think this year the reason why it mainly probably went slow was switching to SolidWorks was a big thing for me, and switching to the whole like GrabCAD, having to upload and download your changes every single night, and having to keep in touch with the library. That was definitely a big change. So I think that probably slowed down the process. But I think to speed it up, getting familiar with that while also communicating with my peers and other committees, and talking with programming and build more is definitely something that'll speed that up.
Our shooter is super reliable, and part of the reason for this is because we're using a closed loop system, which uses the limelight to get the distance and the angle that the robot is from the target. So we turn this distance into an RPM value for the shooter. We use a 6-degree polynomial for this. We actually had to use linear algebra to turn the 7 data points into the polynomial. We use the limelight for auto aligning to the target, and that again is a PID loop. One of the reasons that we're able to score all of our balls into the goal is because we don't allow the feeder and hopper to actually put the balls into the shooter until we're at the RPM and we're auto aligned to the target. This is one of the reasons why our autons were accurate, reliable, even if all we did was drive off the line and shoot.
So Nihar, I heard you guys refer to your robot as knock on wood earlier on in this conversation. And I know 9 times out of 10 that when there is an interesting robot name like that one, there's always an interesting story behind it. So where did knock on wood come from?
Yeah. So first off, as you can see from our robot, there's a lot of wood on it. From the base of our electronics board to our hopper floor and some other structural parts, it's got a decent amount of wood. But I think the most important bit was in the shooter. So initially we had a 2-rail shooter design, and it wasn't as consistent even after we went through several iterations of it. We just couldn't get all the balls to go in. We were having issues with distance or height, stuff like that. So what our head mentor, Mr. Gregory, suggested was that we redesign it to make it completely flat so that the compression of the ball is consistent throughout. 2 days before we have our first competition, Happero Horsham, we were still getting inconsistencies with the ball. But we have this mentor. He's a master carpenter. His name's Mr. Cardoso, and he created a wooden insert that fit almost perfectly between those 2 rails, and it basically made the entire shooter hood flat. And as soon as he added that in, the shooter was completely accurate. Like, it started shooting outer ports like it was nothing. Like, we were crazy accurate, and it was one of those moments where we all breathed a sigh of relief, because we were like, oh my god, we have a competitive robot that somewhat works. And we basically named it the wooden insert that saved the season, which is essentially what it was. And then there, knock on wood, was named.
You guys did not disappoint. That is an incredible story for sure.
The game is awesome to play, and it's really unfortunate that a lot of the teams that we've been competing with in the past didn't get the chance to play it. But I think the big thing was that our robot throughout the event got better as we went on, right? So we had a lot of code refinement, a lot of hardware iterations, and I think one of the biggest was our hopper, which we were still having issues with even come time for Happero. We added these rollers to make the balls kind of get stuck less and kind of flow into the feeder a lot better, and that was a big thing for us. And we also felt that our robot was really robust, so we didn't really come up with a lot of issues. Mechanically speaking, we didn't really have any like blown motors. There was nothing really that broke in the middle of a match, and that was a big thing for us. Obviously, we did have an issue a couple times with our radio resetting, but let's be honest, what team doesn't have that problem? So I feel like our team really came together. And so technically our robot was sound, even non-technically. Everybody in the stands, our spirit and scouting, firing on all cylinders. So for me personally, it was really awesome to say that I contributed to the design of that, standing behind the glass and able to experience that. And I wish more teams got to the experience such an awesome game, and I look forward to seeing it on FMA Plus.
I think Libby and I are both still holding on to hope that we're going to see some sort of playing time, hopefully in the near future. But it's awesome to at least get the chance to talk to you guys about what this game was like, so we can live vicariously through you. What's next for Knock on Wood? What are you guys going to do to make Knock on Wood knockier or woodier or better or more improved?
Yeah, so for the next competition that we were anticipating, we had our climber ready and it was built and it was completely good to go. It also had a skywalker mechanism, which is a self-leveling, we referred to as the skywalker, which really was an ingenious design because it was integrated with our control panel mechanism. So it uses one motor but runs the control panel mechanism and the skywalker mechanism at different gear ratios using a worm gear. So that was pretty cool. And another thing was, even though we went through a couple of iterations at the competition with the hopper jam, we were still having some of it and we could always make it better. So we added a motor that was attached to a compliant wheel that ran counterclockwise to dislodge the balls and try and get a better flow.
Yeah, and from the software side of things, we also added a better spin-up feature for faster initial shooting. One of the problems we were having at the competition was that it was taking way too long from stop driving to finish shooting all 5 power cells. So pretty much that was just PID tuning, making the robot align faster and working out some things with the limelight. Of course, one of the most crucial features to any game is Auton. We had at Hatboro, all we had was a 3-ball Auton that would drive off the line. In our next competition, hopefully, we'll have a 5-ball Auton ready to go that we've already tested. And we're also going to have one, hopefully, that steals 2 balls from the opponent's trench. That one we are still working on.
It was a successful season for us in spite of it, being cut short by unprecedented events. But here on the team, we have a motto. The team is what you make of it. And we saw that that motto was really embraced by all our students this year. We were really successful at getting the best out of everyone. So our leaders and upperclassmen did an excellent job teaching new members skills, and those new members rose to the challenge and the occasion to use them. And we were really impressed with our freshmen who took everything that we as leaders taught them and really used those skills when necessary. And overall, it was just a very positive experience for everyone on the team.
All right, Ethan. So those were some pretty inspiring words for sure.
Yeah, we'd like to thank our mentors. They stepped up while our head coach was out for surgery, and they kept our team on track, growing and learning. We couldn't have done it without you. I'd also like to thank our parents who provided the meals and the Team Mercury Parent Mentor Association for helping raise funds for the team. And we also want to thank our sponsors. We couldn't have done this without your gracious support. So you can catch us at our Twitter at FRC1089, our Instagram at Mercury1089, or our website, www.mercury1089.com.
Awesome look at your robot and your process improvements over the years. We love seeing 1089's robots, and we hope, or I guess knock on wood, that we will see it again soon. Jeff, who's up next?
All right, up next we have Team 2729, Storm Robotics team from Marlton, New Jersey. Now, the interesting thing about this team is you might know them right off the bat for having one of the best chants in First Mid-Atlantic. But Storm is way more than a killer chant. They're a great team, and they have a great robot to show us tonight.
All right, guys, we are here with Pranav, Dan, Arushi, and mentor Mr. Smith from Team 2729, Storm Robotics. Thank you, Jeff, of course, with the very small clap, clap, whoosh here on FMA+. So, Dan, why don't you start us off, introduce us to your team, and what your season started off like this year?
Sure. So, we're Storm Robotics. We've been around for 12 seasons now. And during this year, we had the chance to compete in competition, as well as undergo a couple of big changes. This year, our team expanded to add around 20 members, And so a lot of what we've been focusing on is trying to set up an infrastructure for all of those newer members who have less experience. And that includes training in many different fields, whether it's GrabCAD for design, CNC machine training, or safety training across all departments.
Nice. Yeah. Pranav, maybe you could dive in a little deeper in regards to your electrical and software training. How do you guys handle those two areas?
Well, with electrical, we want to get the basic training, such as like crimping, how to wire a FRC robot, um, how to work on pneumatics. And with software, we wanted to teach the software team command-based programming, how to use GitHub, and how to program our scouting app that we have on here on Storm.
That's really cool. It seems like with 20 new team members, there's a lot that you can do to sort of increase productivity, or you could totally throw off your workflow. So Dan, let's dive into a little bit of what that team workflow is like.
Yep. So we wanted to emphasize having a controlled structure of how we progress through the build season. And so we kind of divided up. Our build season begins with an initial discussion of how we want to play the game, whether it's strategy discussion in large groups that allow all of our members, whether they're experienced or not, to talk. And then we move into two prototyping stages, which we call Whoosh 1 and Whoosh 2, aptly named, because we go through them. They're a little less than a week each. And throughout each one, we're doing rough prototyping and gradually refining our designs. And part of the advantage of having new team members is being able to have more different separate groups. And so we were able to handle a lot of different challenges this year. And we kind of created a bot that can do everything in the game. And after that, it goes to integration. And a lot of that is about communication between our different departments, which is something that we struggled a little bit with last year and that we've been trying to refine this year through things like communication over Trello, keeping track of objectives, and having more regular meetings. A lot of what we did started in the preseason. We started with training with our new members in the preseason with CAD and GrabCAD, so they would be more suited to be able to contribute to the team. And we've also been working to include every component in our CAD, whether it's electrical components like the RoboRio, the Limelight. So we're not just figuring those things out after we already have components set in place.
What kind of workflow do you guys have when it comes to the electronics?
So in the electrical, we also start with a brainstorm. So after we figure out what kind of bot we want and what we want to do with it, we need to think about what components will best fit the functions that we need. So how do we want to actuate stuff? Do we want to use pistons? What kind of motors do we want to use? And for pneumatics, like what's the PSI that we want? So we have to make all these decisions. And then after that, we start on the actual building. So this year we have a belly pan that's at the bottom of the robot where all our electrical components are. And so we started with building that. We also built the gearbox. And then we started to wire up the robot. And then after that, we start testing. So we test our sensors. We test all the basic things just to make sure that the robot will be fine for software testing. And once we're done with testing, we move on to preparing for competition.
Awesome. So, we know how you've got it all set up for electrical. What about for software?
So software, we also start with a brainstorm. And so we organize the functionality into subsystem commands and command groups because we use the command-based framework. And so we just basically figure out, okay, so we need the robot to move forward. So, okay, we need a drivetrain subsystem. And what commands do we need? We would need a drive manually command, a drive automatically command, and so on with like all subsystems. And then we start to program. So we start with the subsystems, which is like the foundation for our command-based framework. So we program everything we need for each subsystem. And once we're done with that and it's all completed, we move on to commands. And so we bring the functionality to the subsystem. So we have like launch for our launcher subsystem. We have automatic indexing for our Celevator subsystem. So we use the subsystems to get things done. And then we have command groups, which are a group of commands strung together. So basically it's like an autonomous mode, or we have one where it automatically aligns and then launches the ball into the target. And so during all of this, we have meetings in the beginning of each of our build season meets, and we kind of see where everyone is at and if anyone has any questions. And we also had a new GitHub workflow this year. So rather than having one branch and everyone merging into the or committing into that, this time we had a default branch called dev, and then we branch off of that and we make our commits to that. And once we're ready, we make a pull request back to the default branch. And that's where the mentors and directors get to look over the code and make sure it looks good. Then when we come to testing, we make a document called testing procedures. So this is what subsystems you're going to test in the order that we're going to test it and what needs to be tested. So we have like a big checklist, and we make sure we use our time efficiently because usually software has like 2 days to test. So we we call someone over and we test it. If it works, we're good. But if it doesn't, we send them back to fix it. And while they're fixing it, we start working on another subsystem.
Makes sense. Arushi, is it called BAM workflow or BAM workflow? How do you guys refer to that?
It's BAM. BAM stands for Business and Marketing. So this is our department that handles awards, outreach, and marketing. So this past season, our only returning members were our directors. We have 3 directors in BAM, one for each of the sub-departments. So when we started teaching our new members, 2/3 of our department were new members, we took like a hands-on approach. So we had a buddy system where if we're writing awards, then there would be one older member with a younger member, and it would help the younger members understand how we write and how the process we go through to submit awards. We also tried to keep our entire department together, even though we're broken up into these like sub departments. Everyone reviews our chairman's award together. We all look over the entrepreneurship award. We all approve button designs. That's a big part of our team. Looking through the buttons, making sure that we have the best designs, and seeing that everyone gets the chance to participate in our marketing. We also have this 3 director thing so that we can meet our deadlines on time. Awards have very, very tight deadlines. Beginning of February, you need to get those things in. Marketing has a looser deadline where we just have to have all our materials ready by competition. And it's up to me as director of marketing to meet those deadlines. And the outreach director is in charge of making sure that we're communicating efficiently and quickly and responding to people who are trying to contact us.
That's a really interesting look sort of into the other components of the team in addition to the build season. So we've talked a lot about prep and getting everything ready for the 2020 season. Let's talk a little bit about your robot. Dan, let's kick us off.
Sure. So our robot is a tall bot, pretty much at the height limit, where we're able to store 5 of the power cells at a time, and we're able to shoot from all distances, whether it's butted up against the target or behind the control panel on the other side, so long and short shots. And we can do that with our shooter, which has an actuating hood. In order to get the balls, we have an intake that folds down, and it covers the whole width of our bot, and that allows us to pick up multiple power cells at a time. And in order to deal with that, we have a hopper, which has belts that spin in opposite directions to deal with getting them into a single file line so that we can store them inside our robot. And we use a little bit of software to help us with all of this.
Yeah, so for the intake and hopper, it's actually just motors, and we run the motor through teleop control. So when the driver clicks a button, the motors will run and run the intake and hopper.
And our robot is also able to hang. We were able to do this in our first competition, and it really helped a lot. So we hang using a gearbox, which has a friction brake on it, so that we can stay up even if there's no power. And we also have a mechanism for manipulating the control panel, which we didn't get to use, but we did testing for, and we're able to do that too.
Yeah, so for the control panel, we have a color sensor, which was given to us in the kit of parts, and it basically returns the color that it's currently seeing.
And one of the other things we also wanted for competition was a bot that was both maneuverable and able to stand its own. So we have a 2-speed gearbox. We're running the chassis with 4 traction tires and 4 Omni wheels, and that gives us good turn radius. And the 2-speed gearbox is what allows us to have high torque in one of the gears and high speed in one of the others. So we're able to push other robots and keep our hold our ground, so that we're able to avoid the zones that we could incur penalties in, as well as have speed to cross the field if we need to make cycles.
Cool. Pranav, can you run us through the autonomous modes?
So we have 2 major autonomous modes right now, which is launch and then drive, and drive and then launch. So what it does is it's a command group where it's a group of commands. And so the drive and then launch, it drives back, it aligns itself using vision, and then launches a power cell or 3 power cells into the port 2 or port 3. And we also have launch and then drive, where the drive team aligns it, and then so we don't need to use vision align. And then we just launch the 3 power cells and then reverse 3 feet.
Awesome dive into the robot. So obviously we said, you guys did get to compete this season. So let's hear a little bit about that. Obviously, not a lot of us have had the chance to compete in Infinite Recharge. So I'd love to hear your reflections on the game and strategy and all that kind of good stuff.
So I've been a driver or on the drive team for the past 3 years, and so each year is a bit of a new experience. This year, I know there was a lot of emphasis on being able to handle yourself in cycles, whereas uh, this year, our team, we kind of focused fully on offense, where last year we were a bit more of a flex spot in what we could do. And so that was a little bit different for us. We were pretty much going for scoring all the time instead of playing defense some of the time. And as for the competition itself, they're great as always. And it was a lot of fun. And we were able to get the Industrial Design Award at our first competition. And so a lot of that was due to our planning in small things like having Velcro to remove panels on our robot so that we could access electrical components. Um, User-friendly things like that we thought of that helped us to get that award.
That's pretty cool, Dan. So, Arushi, what was it like dealing with the judges, or what was the overall judging experience like at competition?
So again, we had only 3 older members on the team. So in terms of judging, we came up with a more effective way to go about it to make sure all the members knew what was going on and they could effectively speak to the judges and convey what information we had. We put up banners so that people could refer to them and make sure that scouting went easier. We could also talk about our tech binder, which was well organized. We also are implementing videos for the Compass Alliance this year, where we are filming ourselves, recording ourselves on how to talk to judges. It's something like passing on knowledge for the years to come and making it available for everyone who wants to find it on the Compass Alliance website. So it's something that we're looking forward to posting and helping the rest of the teams in FMA with.
Nice.
Wonderful. So one of the things you just touched on very quickly here was scouting. Pranav, why don't you talk to us for a moment about your scouting?
All right, so we have a scouting app here on Storm. So we wanted to get information where we could quantitatively measure other teams' abilities with scoring and defense and stuff. So we created a scouting app. And so the way it works is we have 6 scouts scouting the 6 teams, and we have 1 master scout. So 6 scouts are entering all the data into the user app. And so they click submit, and then they generate a QR code. Then the master scout comes with the master app, scans all the QR codes, and it stores all the data into a database. Then when this strategy team comes around, we can dump all that data onto a spreadsheet using comma separated values. And then the strategy team can use that for like drive team meetings and alliance selections.
Wow. That's an awesome approach. I've not even thought of utilizing a QR code for that kind of data transfer. It's definitely better than the old school, clipboards and tons of pieces of paper. All right, so Arushi, Daniel, Pranav, and Mr. Smith from 2729 Storm Robotics team, thank you so much for taking the time to talk with us tonight. Before we go, though, is there anything else that you have to tell us? Anything else you want to share with the First Mid-Atlantic community?
Yeah, so we have a first Compass workshop coming up on May 16th. Of course, it's subject to the situation with COVID-19, but it's essentially a series of workshops ranging on topics from CAD design to diversity, and any team can attend or hold their own presentation. It can be student or mentor led, and you can sign up on our website, stormroboticsnj.org. You can also find our website from our Instagram, stormroboticsnj. Thank you guys so much for having us here.
Absolutely. We're glad to have you on FMA Plus, and we'll definitely look for more information about that first Compass workshop. Thank you guys so much.
We're doing it. One,
okay. Two, three.
Whoosh. We'll run that. Wow, that was awesome. Another great account from a team that had the benefit of playing already this year and this season. Really excited to see where Storm goes from here.
Our next team has not revealed their robot yet this season, but they're choosing to do so on FMA Plus. Last year, they did a live stream reveal on their own, so I'm excited to take a deeper dive into the robot, not only how it performs, but how they built it. So let's check out Team 225 Techfire.
All right, so we're here with Aislinn and Nick from Team 225, along with their mentors, Ben and Donnie. Aislinn, Nick, super excited to learn more about your robot and your team and what you guys have been up to this year. So with that, I'll give it to you.
Thank you. We're Techfire 225. And just before we get started, I just want to thank our sponsors on behalf of the team. It's been a long road, and it's glad to have them on board. So before we get started on the robots, we're going to just do a little bit of behind the scenes, what we did over the summer and what we do as a team. Just a quick highlight out of all the 8 you see there. Just want to talk about Robot on 3 days, our RA3D team, and just how we were able to learn about the game before it even started by utilizing their expertise and also releasing that to the other teams across the world. So how we structure our season is the first weekend after we get the game, we do basically nothing mechanical. We sit down, go over a priority list, and figure out what all we want to do. So basically, first day, we digest the rules, read it 3 times over, and start getting ideas of separate subsystems and the priorities they have. After which time, we then start breaking those down further and further until we figure out what we want to do with the rest of the season. So this year, we had a new machine in the shop, which has been amazing. We were able to design our robot around this new device, and as a CNC. Just a quick shout out to 1923, who were able to help us during this time, getting it set up and getting us up and running before we really fully understood the system.
So before every season, we end up having the same goals pretty much. We always want to build a robot that can win worlds as well as the FMA championships. And the way that we plan to do that is by having insanely fast cycle times, being able to rank high, and being everyone's #1 pick, because that's how generally we win competitions. And as you can see in this graph, the first alliance wins the competition about 60% of the time. And that's why we build our robot to either be the #1 pick or to be that #1 alliance. So to do that, you have to optimize around ranking points.
Yeah, so on this one, you talk about cycling fast, ranking high, and being everyone's #1 pick. Are those the 3 top priorities you have and they're equally prioritized? Or is there maybe 1 or 2 that are, if you had to pick one over the other, or are they, like I said, mutually inclusive?
I think, yeah, generally they're pretty equal in how we rate those, but If I had to pick, I'd probably go with those fast cycles because that leads into having a higher ranking and being more likely to be picked by the other teams.
That
So
makes
they're pretty
sense.
much the same.
Okay, awesome.
So this year, the first thing that we really discussed strategy-wise was whether we were going to have a lower bot or a taller bot. Some of the pros and the cons of each is that obviously for the low bot, you have that lower center of gravity as well as the ability to go under the color wheel in the trench. But only really one robot can fit through there anyways, so we decided to go with the tall bot. Also because it has that better trajectory for those 3-point shots or in the inner port. And that was our design focus this year. So also it had easier packaging with the tall bot. And because it's simpler to fit everything together, it's much easier to just start working on it and modify as you go. A few other of the must-haves that we had this year were being able to have an 8-ball auto or more at least. Another thing that we decided was a must-have this year was the climber. And as a team, we've decided that we always want to be the last one scoring those points on the field. And the way to be able to keep scoring power cells until the very end is to be able to climb in at the most 5 seconds. And then obviously those very fast cycling times are necessary because those, along with autonomous, is what differentiates the different robots in high levels of play. And the way to get those is no jams, and as soon as you your intake touches one of the power cells, you can acquire it. A few of the things that we thought would be nice to have this year is the color wheel, no pneumatics, and an adjustable hood for the reasons listed below. What we thought was not necessarily worth it would be the against the wall shot, a buddy climb, and the Skywalker.
So let me ask you, Aislinn, in regards to the buddy climb, I know that's one of the more commonly disputed features amongst other teams that we've spoken with. Was there anybody on your team who was in support of the buddy climb? Was that, a debate amongst your team, or were you guys kind of unanimously in agreement on its, lack of value?
No, definitely. We always have at least one person who has the opposing view, so we always go through all those opinions before deciding on what our focus is going to be. But the main factor in deciding not to go for the buddy climb was that about 50% of robots for the past 2 years at the FMA chance have had climbers, so we haven't really had to worry about it. So we decided to just go with that data again this year. All right, so the way that our build season work is we send the majority of our students to prototyping as soon as we finish going through the game manual like 50,000 times and discussing all the different avenues you could take for designs. So as you can see in that picture, we had, I think there's 3 different prototypes that are being worked on at the moment, but we had up to 5 different intake prototypes, especially since game acquisition is something we have struggled with in the past. And then we also were prototyping climber hooks at the same time. And then something else that we start almost right away is the drivetrain build, which takes about 4 students. And then we have another student who is just working on the CAD, packaging everything together and making the first iteration of drawings for things like the shooter and the serializer. And then as we finish up prototypes and reach dead ends, we pull off students to begin working on those other systems. This is just an example of one of our intake prototypes. And that is our robot for 2020. It is currently unnamed, but we'll get to that.
We still got to think about it. So first we're going to start off with the drivetrain. We decided to go pretty square this year, 28 wide, 32 long, so that we could have a very wide intake for acquisition. It is constructed with welded VersaFrame. We decided to go with an 8-wheel drive so that we have a firm, steady base for shooting instead of rocking on 3 wheels. This year, since we have no pneumatics on the robots, we have a single-speed transmission with an 8-to-1 reduction with a 13 feet per second. We also decided to go with 3 neos per side and a full bumper wrap.
So, Nick, can I ask you, did you guys ever consider the Falcon 500 motors that came out, or Or did you guys decide to go with a tried and true motor that you were used to, and that's what led you to the Neos?
Tried and true in that we haven't really messed around with them over summer. We don't really know what they did, so we just want to stick with what we know and just make sure in case for whatever reason something happened with them.
Makes sense.
Here's a quick test of them running up.
Have you guys heard about the concerns of using the Omni wheels on the leading edges in regards to the barriers in the rendezvous zone? I heard that some Omni wheels were not handling the damage or the shock load from running into those barriers as well. Have you guys considered a contingency plan for that?
Oh, we definitely have. I mean, if something works out, we'll figure something easily out. And also, if they break, we replace them. I mean, at the end of the day, if we have plenty of parts and a pit team ready to go whenever.
Cool.
All right, so for our intake, we originally had all polycarb frame, but we very quickly realized we needed that extra rigidity of the aluminum in the back, so we added that on. The rotation is motorized via the Neo 550s, and the intake can either be moved all the way up inside of the robot, or we can actually move it down so the wheels are almost touching the floor, and that way we can directly load power cells into the robot via the human player stations. All of the rollers have the vectored intake wheels on the edges just to move those power cells toward the center as well as prevent jamming in that polycarb. The first two rollers have compliant wheels in the middle, as you can see, and then the one in the back actually has Omnis in the center. And then that's rotation is also powered by the Neo 550s through the Versa planetaries. This is just an example of our intake. We're pretty proud of it this year. It's one of the best ones we've had.
Moving our way back, we have the serializer and indexer. So at the front of the robot, we have two star wheels that almost like flop the balls in and help us serialize into one straight line. That as well as attached to the color wheel on a direct shaft all the way up to the height. That we didn't have to worry about a different motor and driving in, such like that. The indexer is constructed in an S shape, with the majority of it being 2-inch wide belts, and everything is compressed inside so that everything maintains a solid position. This year, we also decided to make sure that we have 6 spots open for balls so that any jamming is reduced.
Control-wise for the indexer, we have a time of flight sensor in the front, right where the star wheels are. That actually tracks the number of balls that are entering the serializer, so that shows up on the driver's station. And then it would just reset whenever we shoot, as well as making the spacing between the balls perfect so that they don't touch each other and then get jammed. For the color wheel, we just use the Kitaparts color sensor, and we just use encoder ticks for the rotation aspect of that.
That's awesome.
So for the shooter, we went with a turret design this year with a Neo 550 on a 60-1 going into our water jetted turret gear. On the shooter, we also used our CNC to design and create the shooter. We decided to go with 3 Neos for our shooter. This was to help relieve the recycle time of shooting. So when one ball goes, it's already up to speed when the next ball is ready to go. Each shooter has 3 precision balanced 4-inch Coulson wheels and a 4-inch steel flywheel for additional inertia. In the future, we plan on creating different rails for different game settings and different plans for different target zones as the game progresses. And also, we're planning on cutting out excess material as well.
Yeah, you guys definitely have enough power there. That's for sure. That's awesome.
So for tracking the goal as well as auto aligning, we use the LineLight camera, and that will not only line up the turret automatically, it will also send the right RPM to run the wheels at to make it from whatever distance we are away. In order to keep the wheels up to speed, we used a PID loop. And we also had a little chunk of programming in there that did not allow the robot to shoot unless if the wheels were up to speed. This is just a graph of our PID loop and how much better it got after playing with the numbers.
So last we have the climber. We went with this year with a 2-arm climber that was spring loaded to extend up to heights, and then at the underneath the indexer you'll find 2 winch wheels driven off of a single neo, and that then is released, and then that spring springs out, grab on, and the winch pulls us back down. We're still developing a little bit with that. We were going to get it done, but then things happen. But we decided to focus less on the climber and more with the shooter, because that's where the ranking point is, and also we found more value in shooting.
So for this one, we decided to stay on the left side of the field just in case if our alliance partners could not move out of the way, that we could somehow get over to the other side of the field or something happened. We also have an autonomous that crosses the field, hopefully out of the way of the alliance partners, and then has access to so many more power cells, and then be able to get those other 2 power cells from the shield generator. And then this is just an autonomous to start on that side of the field and still have access to 8 of the power cells.
That's cool. You guys designed in autonomous flexibility. Is that something you guys typically try to accomplish every year?
I would say more it just happens, because when you design for all of the possibilities that could happen in teleop, you generally have more variability possible during auto. But we didn't necessarily design for that, no. We have a TechFire webpage that we created, and on that we can actually update values in the code immediately. And so we have a place on the webpage where we can update the F value, the D value, the P value, and the I value. The way that we do it is we set everything to 0 and then try and get that F just by adding to the F, get that second line, the RPM of the wheels up to the set point, and then from there add to the P and the D in order to get rid of the oscillations.
Awesome. So I have one last question for you guys. You guys packed a lot of functionality into a really, really well-packaged robot. Can I ask, how are you guys doing on weight? Were you right at the limit? Do you have a little bit of extra room to play with upgrades? Or are you gonna kind of go with what you got? Where are you guys at on weight?
So we were actually closer to 113 pounds this year, or 118 with the climber, which is a lot lower than normal. So we do actually have room for updates this year.
Surprisingly, yeah.
That is awesome. Yeah, it's always nice to have a little bit of a cushion there. So, when you get to a competition and inspiration strikes, you can, potentially add something on to make yourselves better. So that's awesome. All right, well, that's going to do it for this segment with TechFire Team 225, the pride of York, Pennsylvania. Thank you, Aislinn, Nick, and mentors Ben and Donnie for your time today. It's always a pleasure talking with you guys, and I can't wait to hear from you again in the future.
Thank you.
Thank you so much.
Thank you, Team 225. That was an awesome look at the robot. I'm so excited when teams who haven't played yet show off their robots, because I just really, really want to see them play Infinite Recharge, and I know that we will get there. If you have any questions about the TechFire machine, make sure you post them in chat. Our moderators will collect them, and we're actually going to do a live Q&A with Team 225 TechFire at the end of the broadcast tonight, so stay tuned for that.
After an awesome breakout year, this next team is super prepared for their sophomore season. Let's hear a little bit more about Team 7587, Metuchen Momentum, out of Metuchen, New Jersey. All right, so we're here with Team 7587, also known as Metuchen Momentum from Metuchen, New Jersey. I'm super excited to hear about this team. They had a breakout season their rookie year, and they're back for a second year. So Jocelyn, why don't you take it from there?
All right, thank you. So this is actually just our second year. Last year we was our first year as its first robotics team. And I think all of us are really proud of the growth we've gone through, since at the start of last year, we weren't really acknowledged by our Board of Education as a team, as a competitive team. But after the competition season, when we showed what we could do, we even ranked 35 out of 128 teams in this region. And after we showed them what we could do, we are now a fully fledged competitive robotics team of Metuchen. And
That's really cool.
We're all really proud of that.
You have a lot to be proud of. I mean, ranking that high in district is an incredible feat for any team, but especially a team that's so new to the program. So obviously you had your first season, your rookie season, which is amazing and incredible and awesome. And then you were going to jump into the 2020 season. What did you guys do in the preseason to prepare for your second year?
So the first thing we did during preseason was, in our rookie year, we were fortunate enough to win a couple of awards. We won 3 rookie highest seeds, 1 rookie all-star, and 2 rookie inspiration awards. But we didn't have a place to display those awards. So over the preseason, we worked with the school to allocate a space.
So another thing that happened during our preseason was that one of our sponsors, the Argosy Foundation, was generous enough to donate us some tools, including a drill press, a bandsaw, and a belt sander, which we were able to fully install in our workshop, as well as make ourselves more of a permanent function in the workshop, which includes labeling our parts, includes ordering new inventory. And we also sought to increase our membership within our school.
With the new members that joined the team, we sort of threw them into an actual season situation where in our rookie year, we weren't able to manipulate the cargo. So we decided that we were going to build an elevator and intake, which could actually get added onto our rookie year robot and sort of manipulate the cargo to all 3 levels. So we had them build an Andy Mark elevator and an intake mechanism, which they looked through a lot of teams and they figured out a design for themselves. They CAD'd it, and we built an elevator with an intake that could actually manipulate the cargos that we weren't able to do our rookie year.
This year, we also realized that we were lacking quite a few things last year. And so in order to make up for that, this year we created some new teams on our robotics team. We got CAD, a strategy team, and a safety team, all of which we had no idea they're really important, and we didn't know that last year. And so we decided to fix that by creating these teams this year.
Nice. So you guys actually elaborated further on your 2019 season robot and used it as a tool to prepare your current and new team members for the new season?
Yes.
That's a great idea. That's a really, really resourceful way to use what you got and become better from it. So props for that. All right. So we've heard about how you presented or how you've prepared for the 2019 season. And you guys, you have a lot of measurable improvements, a lot of great additions, and really exciting upgrades. So now let's talk about 2020. Paige, maybe you can walk us through or start to walk us through the 2020 season and its process for you guys.
Yeah, of course. So we began our season directly after kickoff, the day after actually, with a brainstorm session, and we kind of just worked through different design ideas and what we wanted to make our robot do this year. And eventually we ended up basing our idea off of Team 118's EveryBot design and taking that and elevating it to our own purpose. And so in the sense of electrical, we used a vertical and horizontal hybrid board because we did not have enough space in our robot to make a full board. So we wanted to take advantage of every space that we had and make a fully functioning system that was completely effective while also saving us as much space as possible. We also invested in some new connectors. We started our season off with Anderson connectors, but then decided that we wanted to switch to Wago. So we overhauled the entire system, which was difficult while we were in the process, but I think it really benefited our robot in the end.
On the programming side of things, this year we actually used sensors for the first time because we wanted to be able to spin that color wheel And so we used the rev sensor that was included in the kit of parts and figured out how that worked. It was pretty exciting when we first got it to work correctly. And of course, we also updated all of our code because last year's code was a bit of a mess. This year, we updated everything and we overhauled everything to fit the first standards. So now we know where everything is. We know how everything works. It's super neat now. I love it.
On the mechanical aspect, as Paige already mentioned, our design was heavily influenced by Team 118, the Everybots, and we thank them for putting their resources on the internet and allowing teams to reference it to create a robot. So our mechanical team was split into the chassis team, where we used a long chassis and we added the arm, which instead of using the bag motor, which was used in the Everybot design, we switched over to a Neo because A, it looked really nice, and B, it was way stronger. We learned about the Neo and how to really mount it with the Spark Max, and it was a new experience for both the electrical team and the mechanical team. We worked on an intake which was very similar to the Everybot design, but we added a way of indexing and only being able to hold 5 balls, because the current Everybot design allows you to has space to hold more than 5, around 7-ish balls. So we improved that design by adding a panel to sort of be able to index and only be able to hold 5 balls at max. And then we work on the hanger. The hanger was heavily influenced by the Everybot design, like most of our other parts. And we actually tested it out. It worked successfully, which was really interesting for us because a lot of people on the team can't even like lift themselves up. But like we saw a robot lift themselves up, hopefully gives them motivation to do pull-ups, which was very interesting for us. On the marketing aspect, we got 2 new sponsors on board over the course of the season. The first being Google, and the second, we are actually in talks right now with Altice Mobile for a sponsorship with them. We also decided to switch from blogs to vlogs, trying to make the season and the team more interesting and more appealing to younger members of the Metuchen community and our school. We sort of decided that like blogs, they're like kids might not read them, so we decided to go with like short vlogs so people can watch them and just like see what's actually happening instead of like reading through it. And we think that that really helped our outreach, and a lot of people started watching and seeing the team's progress. The other thing we did during the marketing is we decided to move from Wix to WordPress to create a more professional website. And I believe it's one of the things that's been working on right now. Like through COVID-19 response period, we are working on that website and sort of trying to make a professional, neat website, unlike our website, which wasn't really up to date, or it was a bit of a mess last year. We also have we started Instagram posts over the season, sort of getting the community involved and trying to have them show up to our events, whether it be FMA events or just or school events where we would perform and show the robot off. That are some of the things that we did on the marketing aspect of the team.
So we actually put together this video to share with everyone. So we started off our season this year with obviously kickoff, and we kind of have the full might of the team here. And we also use Bridgewater 303's facility practice field in order to practice driving, teach some of our new members how to operate a robot, and kind of just improve our drive team overall. And that was very beneficial for us because it taught us some new things about driving. And now here we have our fully functioning intake and outtake system, which we use to score on the low port. And our robot also has the ability to hang at the end of game on the hanger. So we thought that was a very important function that we would like to share with everyone. We also got some help from the Team 303's other people who helped us work on our robot and discover some new things that we didn't really know how to do before in order to improve and grow our team's functions.
Yeah, that's awesome. You guys got an opportunity to practice climbing and practice full field driving. That's something a lot of teams don't get an opportunity to really experience until it counts, right? Until you're in an actual match.
Yeah, it was such a great opportunity. Thank you again to 303 for giving us that possibility. And we would also like to thank our sponsors and everyone who just kind of helped us out throughout this season and last season.
Really appreciate the look at sort of your season in your own words and in your own video. So that was pretty cool to look at. Now, usually with teams who are just starting to get their roots, to get their foundation, right, only in your second year of competition, the thing that teams tend to struggle with the most are those sort of non-technical aspects, the marketing, outreach, and sponsors. And it seems like you guys actually have some processes down pat. So Rudy, why don't you tell me a little bit about your outreach, about your sponsorships, in hopes that, you know, some of our rookies or team people who are looking at starting FRC teams will understand sort of how to put down those roots as a community team.
Yeah, I would love to do that. And so basically, our outreach this season's really started with the PTO meeting. We were actually able to demonstrate the robot to the parents and the teachers of Metuchen, who some of them knew about the program, some of them didn't. We were able to enlighten them about the work that goes on in the wood. And then the other thing we did was the Metuchen Country Fair, which was a great opportunity for us because we not only got to demonstrate the robot in front of people from our school, we also got to demonstrate it in front of the people of our community, like the people, my neighbors. We were able to show people, some of the parents from my school, how the robot is, what it is, and what the team is. That actually helped us a lot in gaining membership, and also it sort of brought us as a community team instead of just us solely like a 30-person team that operates out of Metuchen High School. We sort of became recognized in the community as well. The other event that we did was a haunted downtown event where we actually decorated our robot, sort of gave it a spooky look, and drove it around around downtown Metuchen, sort of having young kids look at it and just get interested, and hopefully those kids can become future first members. I started talking with a teacher in my school who actually runs the Unified PE gym classes. For those of you who don't know what Unified PE is, it is a program which combines students with special needs and also like juniors from the school, and they sort of have a gym class together and sort of let them experience gym the same way that everyone else is. Able to actually demonstrate our robot to them, and they drove the robot. The other thing we did was we actually presented in front of the Borough Council, and we're fortunate enough to receive a proclamation from our mayor acknowledging the program and congratulating our successes. The final thing we did, we aided in the creation of an FLL team at Edgar Middle School. They are called the Coding Cows. They also had their first season, started creating a pipeline of students. So by the time they get into FRC, some of them are more experienced. A quick shout out to our sponsors. We have quite a few. We have the Argosy Foundation, Picatinny Arsenal, Holler Metal, who helped us tremendously with cutting metal and creating strong structures. The IEC, which is an environmental company, Google, which was our sponsor this year, Nokia Bell Labs, Metuchen Education Foundation, our biggest supporter, Pearl Street Day Cleaners, the first foundation, and we're in talks with Altice Mobile, and most importantly, friends and families. Without them, we wouldn't be able to do anything that we do.
Yeah, it sounds like you guys are well on your way to a self-sustaining, successful organization, right? If not already there. All right, guys. Well, we had a great time talking with you tonight. Before we go, does anybody have anything else they want to share about Metuchen Momentum?
We definitely plan on going very far into the future. This is a long-lasting program. This is what we're planning will go on for hopefully decades in the future for us. We've actually started creating and distributing sort of learning materials and resources. We really want more teams to be created and joined from other schools as well. And in order to do that, we're actually working with several other teams like 2590, 223, and 303. And we're trying to advocate for a bill to be passed in New Jersey that will support the creation of new teams.
I love the dedication to, being able to advance the mission of FIRST and keep your team's legacy alive. One of the questions I have for you guys is obviously you've been through your rookie year and past your rookie year and into your second season, but if you could go back in time and tell your rookie self something, or if you were addressing a rookie that's starting in the 2020 or 2021 season, what's one thing that you wish you could have taught them?
I would say never give up. No matter how hard something is, keep on going at it. You'll figure out a way around it and you'll get through it. It's like you're going to face hardships all the time, but you'll find a way to get through it.
Don't feel afraid to ask questions too. Other FIRST teams are always there to help, and everyone should community. We should all resource towards each other and really create a helping hand.
I think I'd say the most important thing is that you enjoy what you're doing. This is fun, and I think it's really important to keep that in mind, that even when you're competing, even if you think everything's gonna crash down because your robot broke down right before the competition, this is everything. Everyone will help you, as Paige said, and it's really just about enjoying and learning with your entire community.
Metuchen momentum will definitely stand the test of time. So with that being said, Jocelyn, Paige, Rude, and mentor Pat, thank you so much for taking the time to speak with us tonight. One last question I have for you is, if we want to learn more about Metuchen Momentum and Team 7587, where can we find out more about you guys online?
You guys could follow our Instagram at Metuchen Momentum, our Twitter at also Metuchen Momentum, and you could always send us an email at team7587@gmail.com. Our website is metuchenmomentum.org.
Wow, what an awesome program. Super, super excited to see what kind of sustainability their efforts will produce. It definitely looks like 7587 might be building up some momentum.
In the spirit of puns, let's take off with our next team. We're going to check out Team 747 Flight Crew out of Middlesex, New Jersey. Let's take a look at their robot and a little bit about their community team. Welcome to tonight's segment with Team 747 Flight Crew. We're here with Harshika, Sam, and mentor Jill to talk about the robot, the subsystems, and take a deep dive into the season. So Harshika, let's talk about the team. Give us a little intro into Flight Crew.
We're a community team from Central Jersey, and we work out of a shop in Middlesex, New Jersey called Anson Protective Metals. And actually, we're a very small team. We're only about 19 people, and we have a small number of mentors. So we work with what we have with our resources. But what I found amazing about our team is that we're very diverse. We're from 9 different towns and 13 different schools. And because we're such a small team, we have to consider, like, many other teams have a lot of sub teams, like programming and build. But really, our sub teams are just build and business, and we have frequent crossovers with each other. For example, programming will tighten chains, mechanical will send fundraising letters, and business will end up building field elements.
Awesome. Yeah, it's a really unique experience you guys get with such a small team, and I think the way the team's organized is pretty unique as well. Libby, I know a lot of teams kind of adopt the sub team approach.
Yeah, it's nice to hear that there's sort of we do a little bit of everything, and everybody loves it that way. So that's awesome.
Yeah. So Sam, we've learned about the team and where they come from and how they're organized. Why don't you walk us through the robot?
Okay, so I'll give you a little summary of what our ideas were. So in previous years, mainly last year in 2018, you could see our robots were focused on one key element of the game. In 2018, where we were a switch robot, and then in 2019, we were a defense robot. Going into this year, we wanted to make sure we could do as many of the goals as we can. So we ended up going with was a high and low robot shooter that focused primarily in the closer shooting range, so not deep trench run, but towards the autonomous line and in that range. And from that, we were able to get a pretty successful shooting robot. And with that, we had a robot that can hold 5 balls and is short enough to go underneath the control panel to maximize our cycle times.
So Sam, what do you mean by high and low shooter? Do you mean high in terms of robot height, or Maybe you could elaborate a little bit on that.
Okay, so by a high and low shooter, we mean that we have the capability to fire balls into the outer goal, the big hexagon goal, the inner goal, which is the little circle in the upper portion of the target, and the low goal, which is where you can dump the balls in. We can go between them.
That's really clever. I like the versatility on field. So, robot's name. I want to hear about it. I always love robot names and robot stories. So, what did you decide to name the robot this year, and why?
So we decided to name our robot Charlotte for a very specific reason. There's actually 8 wheels on our drivetrain this year, which we'll get into later. And on our intake, it looks like there's little tiny fangs. And we're like, oh my God, that looks like a spider. So we were inspired by Charlotte's Web, and we decided to name our robot Charlotte. And because of that, there's a bunch of spider-like stickers and designs all over the robot.
Definitely one of the more wholesome robot names, I think. Sam, why don't you walk us through Design Weekend and how that works for your team?
So Design Weekend is our approach to how we get major ideas for the robot at the beginning of a season. So when the game is released on that first Saturday, a core group of students and the mentors get together in a room for, I think it's about 8 hours, and we strategize the main key points of the game and how we think teams will approach it. And then we do that on the next day, the Sunday too. And what we try to come out with out of this Design Weekend is not any sort of robot design like what we've done before. Is we've gone down rabbit holes where we say, oh, we're going to have a robot that will climb with 6 bars that unfold in 7 directions, and we'll have 6 motors on this port. But always by the second week of the season, we end up realizing some key factor that we didn't notice during Design Weekend. So what we do is we try to come up with, again, key points for the game, how it's going to be played, and we're going to move forward with that information.
Cool. I like the focus on, we hear that from some teams often is, we don't want to get too bogged down or down the rabbit hole if it's going to be exactly this design. So I like the high level view. So as you start to think about what the robot's going to be, Harshika, tell me a little bit about your prototyping process.
So we actually went through a lot of prototypes and a lot of iterations of many parts of our robot. But first, I'd like to say that we start all of our prototyping in wood, which I'm sure a lot of teams do. But we also have this spreadsheet of different balls to watch their conditions while we're prototyping. Because we've realized as we use the balls more and more, they go through wear and tear, and it's important to note the condition of these balls.
So one of the main parts of a robot, which we really haven't gotten into yet, is what we call the aileron. It's just how we adjust the angle of our ball. We'll get into more detail with that later. But in prototyping, we ended up going through 5 different iterations of this aileron system. We started with a 3D printed curve, then a piece of Lexan, then Lexan with aluminum backing, and then another printed piece. Now we're finally on a PLA aluminum hybrid that seems to work really well for us. And this came with multiple failures and many tests and really proved our prototyping design.
So we've had many different versions of our indexer, but the main one was to prevent our pinch points. We first did this by having our indexer bands rotate in one direction and then switching them to different directions. So what that means is one will go in and the other one will go out, but then we oscillated them to prevent these pinch points.
One other thing that we replaced was the 4 outer wheels on our robot. Initially, we started with 2, and this is one side of the robot, 2 blue nitro wheels on the inside, and then 2 Omni wheels on the outside, so 4 on each side, totaling 8. But then we saw a Chief Delphi thread that someone posted from a week 0 competition where the Omni wheels were destroyed by driving over the center rendezvous point aluminum bars. So we ended up swapping those out for gray traction wheels just because we did not want to run the risk of breaking them during competition.
Nice. So Harshika, Sam gave us kind of a top-down overview, like a higher level overview of the robot. Perhaps you can go through some of the subsystems more specifically and give us more of a deeper look into those subsystems themselves.
Yeah, definitely. So I'll start off with the drivetrain. We have 8 wheels. 4 are the inner blue nitro traction wheels, and 4 are the outer gray traction wheels. And like Sam explained before, the inner wheels have more traction, which allows for smoother rotation, basically. These wheels are powered by 4 Falcon motors, 2 on each side, and we also have an auto-shifting mechanism. With the intake and indexer, we basically have rollers that are compliant wheels, and they're powered by a single 775, and the indexer sorts balls into a single stream. Basically, we have 2 bands running in opposite directions, and they alternate these directions every second to jostle the balls. For the transfer and shooter, we have the transfer, which is a single wheel shaft with compliant wheels, and it guides the balls basically into the shooter. And we also have a brake beam, which is kind of like that sensor you'll see in garage doors, and it's used to preload the balls right before it reaches the shooter. The shooter itself is a 4-inch flywheel powered directly by a Falcon, and we can control the trajectory of the ball from RPMs and the angle of the aileron. And the RPMs basically control speed, and the aileron is our adjustable flap, which is controlled by PID. Lastly, we have the climb, which is actually heavily inspired by 2056's 2016 climb. It has a winch that is powered by 2 Neos through a WCP gearbox, and it's basically like 6 stages loaded under a spring force. We have a little pin that when it's released in the winch gearbox, the climb basically shoots upward, and then the robot can drive right underneath the bar, and then as soon as the robot hits that bar, the winch is driven and it pulls us up, and a pin is put into the gearbox. This basically locks us in place. And
That's an awesome look at each component of the robot. Now, Sam, I know you guys have done a lot on sort of automation and sensor work as well. So why don't you give us a deep dive into that side of Charlotte?
Okay, so the majority of the time with programming on the robot was spent doing the autonomous tracking. And the autonomous tracking is split up into, I'd say, 3 major sections. I'm going to go through all of them, hopefully. And what I'm going to start with is the system that we use to automatically adjust our aileron and RPM to face the target. So we use a variety of sensors and devices to achieve this. We use 3 actually for the process. First, we use the limelight to get the angle to the center of the goal, and that's just used to turn. It gives us a good measurement of how far we are away from the target, just a range. That's not how we do it at the end of the process, just because it's not that accurate, but we use it for a couple of our intermittent calculations. The other sensor that we use is called the LiDAR. It is a laser beam that fires a point out and comes back, and it gets our distance. The final sensor we use is the encoder on our aileron, and that is just used to control the position with PID, and that is done in its own code. The actual auto tracking mechanism can hit a target anywhere within about 13 feet of the goal. This is only the auto tracking portion. We can make our own presets to fire from the trench run or anywhere else, perhaps in the rendezvous point. It's just that the auto tracking system with the auto adjustment is within 13 feet of the goal. So the process itself to do the auto tracking, this is going to be a deep code like system explanation, is split up into about 10 steps. Firstly, think about this, since the limelight has a vertical field of view, I believe, of about 40 degrees, it cannot see the target if it's at a low position on the robot from anywhere on the field. Because imagine if you're only about 1 to 2 feet away from the target, you're not going to get the vertical field of view to see how aligned we are. So we actually had to put the limelight on a servo, and that will we adjust that angle to see the target. So the first thing that happens is we move the limelight up to about a general position based on our LiDAR distance. And that's going to say, oh, let's get the target within the field of view. And then that is going to just allow the limelight to see us so we can center ourselves on the target. So once we center ourselves on the target, we're able to know, okay, the LiDAR that's pointing forward is reaching the center of the goal. So this is saying, oh, okay, the distance that we're reading is the correct distance. We're not aiming at the corner of the driver's station, which makes like a fake distance because it's slightly protruded out, and that would give us like a foot or 2 less than what the actual distance is. So once we get that distance, we plug it into an equation that we made. And actually, this equation was gotten from a Desmos link posted on Chief Delphi at the beginning of the season. Someone made a simulation to explain how to fire balls with a certain angle and RPM, and we use those equations. We derive the equations from their simulation and put them into our code. So based on the distance that we get, we're able to put that into these 2 equations. Or when you press the button to track, it will automatically turn, adjust the limelight up to face the target, move the aileron to the angle it should be, and spin up the flywheel, which is the shooting mechanism, to the speed it should be running to hit the target at that distance.
Okay, so Harshika, I'm going to pick on you for this one. Any other stories you guys want to tell about Flight Crew, the team, and the community that you've built?
Yeah, definitely. So since we're a community team, a lot of what we do depends on the outreach that we do. So one of the first things that we do is that we go to the American Legion, our local one, and we volunteer at their events where we serve food basically for their breakfasts and their dinners. Another thing that we do is that we go to the local toy drive around the time of the holidays. We basically go to the local fire department and we help them collect and organize toys for their toy drive. And perhaps one of the most important things, at least personally, that's what I think, one of the most important things that we do is that we do stream team. About every month, the team gets to go out and clean out the local rivers and streams with the Central Jersey Stream Team. Moving on to our recruiting process, obviously, since we're a community team and not a school team, we need to care about how we're going to increase the longevity of the team. So one of the first things that we do is that we have open houses. It's basically like a mini presentation of each department that we have on our team.
It's really great to see the perspective of a community team and how you build your roots, which is definitely different from the journey of other teams. I love 747 Flight Crew. I love the imagery, the brand, and one of the things I hear a lot is fly the plane. Sam, can you enlighten me on what that means?
Yeah, it just so happens that this term aligns very well with our name and our number, but I don't think the message behind it is required for a plane-themed team. But fly the plane really is based on the idea in aviation when there's anything going wrong. Let's say your plane is falling down out of the sky, you've lost all 4 engines. All you can do is continue to fly the plane. No matter what, you have to land the plane. So in terms of the team, we have to apply this to what we do. So imagine we're in the pit, we lose 6 of our 8 wheels. All we can do is continue to work on the robot and hope for the best. So we use the term fly the plane just to basically say continue working. We have to continue working and get it done.
I love it. That's such a great perspective on sometimes you really can't control what's going on at an FRC event and you just got to fly the plane. So Flight Crew, thank you guys so much for the insight, the deep dive into your robot, the automation, into your community outreach efforts. Where can I find more about 747 if I wanted to find you online?
So we're basically on Instagram, Twitter, Facebook, and YouTube, all with the handle at Flight Crew 747. Or you can just head on over to our website at frc747.com.
Awesome. I will make sure to check all of that out. So again, Harshika, Sam, and Mentor Jill, thank you guys so much for your time tonight on FMA Plus. We have loved getting to look at Charlotte, the robot, the build process, and everything about your team. And we hope we can see you on the field soon. Thank you so much for your time tonight.
Thank you.
Thank you for having us.
Thank you, Flight Crew. I loved the awesome comprehensive look at your robot. It looks beautiful. It looks like it's going to perform well. And I love sort of the autonomous tracking and all of the sensor work that you guys are doing. And I liked learning about Fly the Plane and how that resonates with your students.
All right, well, that closes out our lineup for week 2 of FMA Plus. Make sure you guys stick around for the post show featuring a live Q&A with representatives from Team 225 TechFire.
Guys, we are back. We are here live with Team 225. Thank you guys for tuning in for the show, for everything here on FMA Plus. Jeff and 225, good to see you, Jeff. Who do we have from 225 as a part of the show today?
Yeah, absolutely. So tonight we have a solid lineup from TechFire. We have Elizabeth, Aislinn, and Tiana, 3 student representatives from 225, along with their mentors, Ben and Donnie.
Awesome. Well, thank you guys all for being here.
Thank you.
So we have a couple of questions that we can start with that we actually got in the first Mid-Atlantic Discord ahead of the show. We have, how does 225 scout?
Hi. So first of all, we have like a couple of things that we do, but we have at competition, we have several team tablets that have a scouting app that we change every year. And it's an awesome tool because it allows us to efficiently put down every little piece of information on the robots we see on the field at competition and moves the information to a website that it allows us to easily get a good look at a team's capabilities efficiently. And then we can use that data from that website to look at our allies and our opponents for upcoming matches, to see for qualification matches. And then also it's super important because if we get a captain's position, then we can use it for alliance selections.
Makes sense. Yeah, you guys are super data driven. That makes a lot of sense, especially in competition. This question definitely piqued my interest, coming from a community team myself. You guys are also a community team not associated with any one school. So the question is, how does TechFire 225 recruit members and keep people interested as a community team?
Right. So the main way we recruit is by word of mouth. And typically it comes at our sponsor presentations. I recall multiple times when we've gone to present to a sponsor and an employee of that sponsor has come up and said, hey, I have a daughter or son who is perfect age for this. How can they get involved? Or their child is too young to join our team immediately, but they want to join some part of first. And though that might not benefit our team instantaneously, it helps with the pipeline so that we will see that member come to our team down the road.
Cool. So you guys are setting up your own feeder system to keep members coming in as, the older members are aging out. Makes a lot of sense.
I mean, that's good advice, regardless of being a community team or a school team. It's nice to know, for example, that a couple of years out, you're going to have your teammates kind of ready and queued up for you. So again, a couple of our questions are sort of more systemic 225, and then I think we'll dive into your robot. So the question that we have from Discord is, how does 225 pick and train their drivers?
Okay, so ultimately with driver selection, it is our coach's decision, but there's a lot of different stuff that goes into that besides just skill. We do have a off-season training, and we have them drive at our off seasons, and we do look at that as part of the decision. But then we also look at attitude, communication with other teams, their competitiveness, their strategic ability, and then also just their strategy skill.
Nice. Yeah, I think the psychological aspect of a good drive team is vital, right? And especially the chemistry, I think. All right, so here's the next one for you guys. Obviously this year was our first year without the stop build deadline, or no bag or crate or whatever you want to call it, crate for the older FRC alumni amongst us. So the question is, did 225 still build a twin robot this year with the bag changes?
So we kind of did. It was almost a twin robot. We did make our first iteration of our robot, which would normally be like our practice robot in air quotes. And we went through that and we put everything together and we tested things and updated them. And the updated mechanisms are what made it onto our comp bot. And that just allowed us to get it to programmers earlier and drivers earlier, and as well account for the wear and tear that it will go through during the season.
Sure. We've got a question straight out of the YouTube chat here, which is, how does 225 choose which competitions to go to for the season?
All right, I guess I'll take that one. We generally have a pretty set competitions that we generally go to. This year we did decide to go to Robbinsville just as something new, but that's more just the competitions that we've been going to.
Sure. I like the idea of sort of like going to different ones, right? You throughout the season, you can sort of like throughout the years rather, you can sort of say like, oh yeah, well we always go to this one, but like maybe this year we'll try something different and we'll see some new teams. So that's always fun.
Yeah, here I'll jump in. This has been on the mentor side because a lot of the times we work with the board of the nonprofit to make those decisions. This usually we try to do at least a week 3 and start and then balance out with the week 5 to make sure that we have the time required to build these robots and get them where they need to be. A lot of the times the robot isn't really, it's still being finished up week 2 of competition season. So that gives a little bit of background there.
Okay, so then maybe a second question talking about the build schedule and how that dictates or at least impacts your event selection. What kind of impact did no bag have on your event selection? Did you guys decide to play early or play late, or how did that factor in?
I don't think it really made a difference as to which events we wanted to attend. We still wanted to do Robbinsville, which was week 3, and we've always done week 3, and then week 5. And once again, we've always done week 5. More than anything, the advantage to no bag day for us was that it gave us more time to practice with autonomous and really fine tune it. And our autonomous is, well, one of the things we're known for.
Nice.
Just to add on to that real quick, the reason why nothing changed competition wise was because we still bagged internally.
Oh,
so
interesting.
that actually, I was gonna say, that actually it speaks pretty directly to a question we're getting out of the chat right now, which is, what are some of the deadlines on 225, right? Like, we, make sure everything's in CAD by blank, or the whole robot is ready by XYZ date. When you say you bag internally, let's dive into that. What does that mean?
Yeah, so we still had the same deadlines as in the past. There weren't any hard deadlines necessarily, but we had our bag day set for when bag day would be set in the past, just so that we wouldn't get behind and get in the mentality that, oh, there's no bag day, we can take as long as we want to build the robot, because obviously we still want to get it to programmers and drivers. And then nothing gets fabricated without CAD, so in order to get to that bag day and have our robot built, we have to have those drawings from CAD first.
Makes sense. Yeah, I'm sure that must have been an interesting response. Like, well, you know what? We're they said there's no bag day, but there's a bag day and we'll be ready for it. That sounds like a good approach for sure. Cool. So now we're going to move into some more of the more technical questions in regards to your robot and your processes. Now that we've covered some of the higher level, observations of the team and how it works. So the first question is, how much CAD design work do you do before starting the drivetrain build? Are you ever worried about the dimensions you select from the drive not lining up with the rest of your design?
Yeah, like I said before, everything gets CAD'd before we build it. So we have our drive team, not drive team, my bad, our drive base CAD'd already before we get in there. So we have 100% of the CAD beforehand, so we know that it's going to be correct.
So dedicated to CAD, you even CAD the whole drive team. I'm so impressed.
Yes.
So again, sort of diving in now that we've seen the robot, so we had a question from, I think this is from the FMA Plus crew actually, is given that you guys use the star wheels to index and center the balls once they're inside the frame perimeter, why did you stick with using Mecanum wheels on the intake as well?
One of the main advantages for us using Mecanum wheels on the intake was that we wanted to make sure in our design of the intake we could grab balls from a wide perimeter around our robot. And so when you have all of those balls coming in at once, we wanted to make sure that they got filed into that portion of the robot. And yes, the star wheels help file them into the indexer, or pardon me, not the indexer, the serializer. But having those Mecanum wheels help put them in order before they get to the indexer, which is really useful because then there's no jams on what is practically the inside of the robot.
Okay, so it just sounds like the star wheels were good in one application, and maybe the Mecanums were just better suited for the other application, right?
Yeah, I would
Cool.
say so.
Okay, next one up. What method do you guys use for your autonomous? So this person actually appreciated the fancy curves the robot drives in autonomous and said they're super impressive. Do you guys use Pathfinder, some sort of PID function, something else?
Yeah. So we have our own autonomous sequencer, which goes through our custom autonomous steps, like a command group from WPI Lib. And then for control, we use the PID and sigmoid ramping for all of our drives and turns. So for those fancy curves, it was probably just an arc turn step where we just put in like the radius, the angle, the power, and the direction, and then it lays it out for us.
Sure. Actually, speaking of the PID control, one of the more specific questions out of YouTube chat was, I saw in the programming section you guys were using a graphing software to use to plot the loops. The name in the corner was they thought they read it off the screen was Firescope. Is this a custom program, or is it something that other teams have access to?
Yeah, that is a custom program.
Oh, okay, got it.
I want to add here that we make our code public. So at the end of the year. So if you're interested, feel free to check it out.
Do you guys make Firescope public, or is that a tool that you prefer to keep to yourselves?
100% public.
Nice. Sounds good. Next question for you guys. You talked about in the beginning of the presentation for 225, you talked about the RI3D team that you guys have been a part of and started up over the last 2 seasons, if I'm not mistaken. So the question is, does participating in RI3D affect the 225 competition design and build?
What RI3D does is it gives an educational platform for not only us, but and not only FMA, but for FIRST internationally. And the main reason it does so is because we can see what struggles have been had by the RI3D team, so that we make sure we know what to spend more time on during the course of the build season. However, I would say in terms of our actual design, we can draw inspiration from what they've done and what they've discovered through the various testing, but we don't directly copy anything they do.
Yeah, I can tell you from a personal perspective, and Libby, I'm sure you would agree, the First Capital RI3D videos definitely tipped us off on needing to take it seriously how we were going to handle the game pieces this year. And that's probably something that I personally would have probably underestimated had it not been for
sure.
that.
Yeah, I mean, so some of our mentors participated in First Capital RI3D as well, and our kids were sort of we've always sort of looked at RI3D as a place to understand prototyping and not necessarily as a sort of like a blank copy. But our kids kept saying like, oh, great, like it would have taken us a week to figure that out. So at least we know to listen to it, and it was really helpful to have, I think, the First Capital RI3D resources available to teams. So thank you for sort of like sacrificing some of your early time and your mentor's time to do that. So another question out of chat, more specifically about CAD, is just what CAD software does 225 use?
We use Inventor 2020. We have for a while. Yeah.
Nice.
Okay. There's one question out of chat here that I find pretty interesting, and we don't have to go super in depth because this is a bit of a longer question, but each year in January when the new game is announced, what process does 225 go through before they even start to CAD? Is there a massive strategy design meeting, or what does that look like? And we don't go super crazy, but you know, give us the high level picture.
All right, I'll take that, I guess. So as soon as the game is announced and we get the code for the game manual, we sit down, we read it like 3 times at least at first, and then we break and come back and we read it again. And then finally, we can go through what we think is going to be like most important to maximize points at that time. And from there, only after we have a full understanding of all the rules do we start talking about designs. And then Elizabeth, if you want to add to that.
Yeah, something interesting that I think we do that I really enjoy is that when we are, after we have gone through the manual and we have a full understanding of the game, after we've gone through it several times, we do a priority list like Iceland said, and it's really a really good time because we get to debate everything and talk about what we want to do. And then later on, I think it's like maybe like a couple days later, everybody is supposed to bring an idea to the table, draw up like a robot. And I think Donnie calls it like a pixie dust robot, a robot like if we could do whatever we wanted. And it's just, it's really interesting because it gets the ideas and the creative juices flowing.
We also get to play out the game with humans, which is really fun, but
Yeah. On my team, we call it the cloud of mist robot. Like you don't know exactly how it's done, and like it could be absolutely anything, but like what would you put on the field if you could do anything you wanted? So I love hearing the different ways teams describe that.
Cool. All right, last question, and I think we're gonna pick on Islin for this one. Islin, you've been super instrumental in TechFire's involvement with FMA Plus earlier this week, and then also tonight during the live Q&A. So this one's going to you. We're going to put you on the spot, and this might be a little bit controversial, especially amongst your team. But my question to you, Islin, is what do you want the name of your robot to be for 2020?
Okay, so I can't say the name that I actually want it to be. So, one really funny suggestion we had was actually from Tessa, and it was about she wanted it to be named, it was like, oh my gosh, how did she say it? It was like the Chewbacca one, it was like Chewbacca Fire or something. It was really weird.
Nice.
So
Yeah, but
let me add to that. So we do put a constraint on the name that it has to have the word fire in it. So if you notice our last, I think 3 or 4 years of robots, there is a fire in the name. So you get very interesting results. Maybe we'll post the results that we've got that we have in our voting this year. We'll think about that.
Cool. All right. Well, I think that's it for our Q&A session with TechFire 225. That's it for the chat questions and everything else. So thank you, Team 225, for your time today. And to all of you at home, don't forget to have your lead mentor check their email information on applying to be on a future episode of FMA Plus.
And of course, thank you guys, 225. You guys rocked it. We love seeing your robot and hearing your answers to questions. Of course, we want to give a huge thank you to our entire FMA Plus crew for making this happen. We couldn't have done it without this whole group screening, interviewing, and editing down these team features, as well as moderating chat tonight, coordinating social media, and keeping you informed.
And I'm not going to mess up my line tonight. We'll see you next Saturday for even more team stories and another awesome episode of FMA Plus. Have a great night, everybody.
And don't forget to wash your hands.